Our question is 2x squared d square y by dx square minus x dy by dx plus x minus 5 into y equal to 0. We have to find a series solution for this given differential equation in the interval 0 less than x less than r. That is, here r stands for the radius of convergence. It's not the real numbers, but the radius of convergence. Now, what we are asked to find is a series in terms of x. So, if you want to use the normal method, that is the method we are using for ordinary points, then definitely x not equal to 0 should be a ordinary point. Now let's just check whether x equal to 0 will give you a ordinary point. It's clear from the equation itself. Even if you don't just try and do the equivalent normalized form, clearly here x by 2x square will give us 1 by 2x. So x is equal to 0 is not an ordinary point. So the previous method is not going to work. Here we'll have to use the Frobenius series. Even if you want to use Frobenius series, first we have to make sure that x equal to 0 is a regular singular point or not. Now let's check whether x equal to 0 is a regular singular point. And now this is very important for us to use Frobenius method to find a solution. How are we going to check whether x equal to 0 is a regular singular point or not? The format is x minus x naught into p1 of x and x minus x naught the whole square into p2 of x. Both of them should be analytic at x equal to x naught for the singular point x equal to x naught to become a regular singular point. Now we are concerned only with x not equal to 0. Let's try x into p1 of x. Here this would mean x into, what was our p1 of x? P1 of x would be minus, of course, minus x by 2 x square. This is going to give you minus 1 by 2, which is constant and is analytic everywhere. Now what about x square into p2 of x? X square into p2 of x is going to give you x square into x minus 5 by 2x square, which is equal to x minus 5. This is a polynomial and again that is analytic everywhere. So our x into p1 of x and x square into p2 of x is analytic. Therefore, x equal to 0 is a regular singular point. That is, it has a speciality that it is a regular singular point. So we can use Frobenius method to find a solution. Now let's see how we can do that. Okay, I have substituted for y as the series sigma n equal to 0 to infinity cn x raised to n plus r. Now my y dash will be sigma n equal to 0 to infinity n plus r into cn x raised to n plus r minus 1. And my y double dash gives the same summation sigma n equal to 0 to infinity n plus r into n plus r minus 1 cn x raised to n plus r minus 2. Now I have substituted all these values into our equation. Now let me name this as my first equation. This is my first equation. Here goes my d square y by dx square as this term. Also my dy by dx goes here and my y goes here. Okay, I have substituted all the necessary things. Now as before, what we are going to do is we are going to change, we'll just write first, we'll have to multiply all the necessary things inside. So let's try that first. Let me write this as okay, sigma n equal to 0 to infinity n plus r into n plus r minus 1. I got it over here. Cn into x raised to n plus r minus 2 into 2. Okay, plus 2. That means n plus r minus sigma n equal to 0 to infinity n plus r cn x raised to n plus r. I have a next 2p multiplied with this term, so that becomes x raised to n plus r. Plus, let me expand this, sigma n equal to 0 to infinity cn x raised to n plus r plus 1 minus 5 into sigma n equal to 0 to infinity cn x raised to n plus r is equal to 0. This is our substituted equation. Now what we have to do is we have to change all the terms to the lowest power. That is, we have to change everything into x raised to n plus r. Now this term is okay over here. Here also no problem. This is the only term where we have to change it. So let me group all the x raised to n plus r's. That will give me sigma n equal to 0 to infinity. I've got 2 into n plus r into n plus r minus 1. And from over here, fine, I'm having a Cn also as common term. So I'm having minus n plus r from here, n plus r. Now what else? I'm having a minus 5, and for everything I got a Cn attached to it. So this is into Cn into x raised to n plus r. Now this is the only term where we have to change the power. This is x raised to n plus r. I have to change. I'm not going to introduce a dummy variable at all. You can just try put in the dummy variable, no problem. I'm just going by my logic. X raised to what I need here is I have to change this thing to n plus r. So when I'm giving n equal to 0 over here, my first term will be c naught and x raised to r plus 1. So I need an r plus 1 over here. For that, I have to put n equal to 1 to infinity. Okay. When x raised to n plus r plus 1 is the power here, my suffix of c is just n. That is, when I'm having n plus 1, my suffix is n. So here what should go? C, n minus 1 should be okay. Now we have sigma n equal to 1 to infinity, c, n minus 1, x raised to n plus r is the reverted series. So this is equal to 0. Okay, now we have got that. Let's see what next. What's the next step? Next step is actually we have to make the summations to the lowest one. Now the smallest summation is over here, so I have to put the summation also in the form of sigma n equal to 1 to infinity. Now I have to put n equal to 0 over here and write this all other terms as sigma n equal to 1 to infinity. When n equal to 0, I am having 2r into r minus 1 minus r minus 5 into c naught x raised to r plus all other terms goes into the summation sigma n equal to 1 to infinity 2 into n plus r into n plus r minus 1 minus n plus r minus 5 whole into Cn plus sigma n equal to 1 to infinity Cn minus 1 x raised to n plus r is equal to 0. Okay. This is where we had left off before. This is our final equation. Now we have to equate the coefficients. We have to find the coefficients. To find the coefficients, we are going to equate to 0 the coefficients of the lowest power of x. The lowest power of x will be x raised to r. So that is 2r into r minus 1 minus r minus 5 into c naught is equal to 0. From there, I'll have c naught cannot be equal to 0. So these things should be equal to 0. That is 2r square minus 3r minus 5 is equal to 0. Now this equation has got a name. This is known as our initial equation. Now we have to find the exponents. What are exponents? Exponents are the root of initial equations. Now, whatever root we are getting, that root has got a name, that is known as the exponents of the given differential equation. Okay, to find the exponents is just a simple quadratic equation. We can solve and find our r. Now we will get our r as r will be, in this case, r will be equal to 5 by 2 and minus 1. These are our exponents. So now corresponding to each exponent, we are going to find a solution. Now first we take r equal to 5 by 2 and substitute in the above equation to get our coefficients. Okay, this is where we left off. 2r square minus 3r minus 5 into c naught x raised to r plus. This is the whole term of x raised to n plus r. We had equated this to 0, and we have got that r is having two values 5 by 2 and minus 1. These are known as the exponents. We are taking the first case where r equal to 5 by 2. Now the next step would be to equate the coefficients of x raised to n plus r to 0. When we do that, we get 2 into n plus r. Here r is 5 by 2, 2 into n plus 5 by 2 into n plus 5 by 2 minus 1. That will be n 5 by 2 minus 1 will give me 3 by 2. Okay, minus n plus 5 by 2 minus 5. Minus 5. This whole thing into Cn plus next term is Cn minus 1 is equal to 0. Now I equated the coefficient of x raised to n plus r is equal to 0, and I have also substituted r is equal to 5 by 2. Now when I simplify this, what I will be getting is, just simplify and do it, we will get 4n square plus 16n plus 15 by whole divided by 2 minus n minus 15 by 2, this whole thing into Cn plus Cn minus 1 is equal to 0. Okay, now again simplifying, the next step will give me 2n square plus 7n into Cn plus Cn minus 1 is equal to 0. Now I'll get my formula for Cn as Cn is equal to minus of Cn minus 1 divided by n into 2n plus 7. Here n is greater than or equal to 1. Okay, let's start case 1. I have substituted r is equal to 5 by 2 in the above equation, and I equated the coefficients. Here I have substituted r equal to 5 by 2, and this is what I get. Now this my Cn will be minus Cn minus 1 by n into 2n plus 7. For each value of n equal to 1, 2 and 3, I am calculating just to 3 up to 3 coefficients. I get C1 is equal to minus C0 by 9, C2 is C0 by 198, C3 is minus C0 by 77722. Now with these values of C1, C2, C3, I am going to write my first solution, one part of the first solution. Okay, using these values of C1, C2, etc., we obtain a solution corresponding to the first exponent, that is r equal to 5 by 2. This is one part of our final solution. Now y is equal to, this was our series expression, C0 x raised to r plus C1 x raised to r plus 1 plus C2 x raised to r plus 2 plus C3 x raised to r plus 3 plus etc. I am substituting the values of C0, C1, C2 and C3. Now I get C0 x raised to 5 by 2 minus C0 by 9 into x raised to 7 by 2 plus etc. My C0 x raised to 5 by 2 is common. I have taken that outside, and inside I will get this kind of a series. Now this is my part A. I have to find part B corresponding to r equal to minus 1. That is also pending. I have to follow the same technique to find the part B for the final solution. Put r equal to minus 1 in the previous recurrence relation and find at least up to 3 coefficients, C1, C2 and C3. Now let's see what we will get. Now I put r equal to minus 1 in this equation, the recurrence relation, to get I'm simplifying everything and I'm coming down to 2n square minus 7n, Cn plus Cn minus 1 is equal to 0. Now this is what I get as Cn. I calculate C1, C2 and C3. These are my C1, C2, C3, and from there I get my second part as C0 into x raised to r plus C1 x raised to r plus 1 etc. Now I am substituting, this is my final answer corresponding to the exponent minus 1. Now get the final solution. What we have to remember is that both A and B are solutions of the given DE, but it's not a general solution. To obtain a general solution, we just write the both solutions as a linear combination of both A and B. Now instead of C0, I am writing it as capital C1. Any constant will do. That's why I am writing it as just another constant C1. c1 into x raised to 5 by 2 I have written down.